right, so we've got a variety of functions and tables here. We want to know for each one, is it an exponential function or not? So remember, an exponential function has the form y equals ab to the x or ab to the t. So if we look at this first one, f of x, we see x to the third, and we see this is just a constant. So this is a cubic, right? This is a cubic that's been shifted up. This is not, so it's a polynomial, not an exponential. So this one is a no. So this is a polynomial, not an exponential. Now the next one, the g of x equals 6. Okay, that's a constant, so this looks like maybe my a. Then I've got 1/4. That's like a b, and my x is in the exponent, but it does have an x plus 1 on it. So we can do a couple of things here. We can realize that this is kind of like, or this is an exponential function that has had a horizontal shift applied, right? Because we basically changed the x coordinate, we've changed the x input. Instead of x, we've got x plus 1, so this is a shift to the left. So this is exponential, so this is a yes, exponential. So we can either think of it as a horizontal shift, or we can look at this as 6 times, remember, 1/4 to the 1 times 1/4 to the x. Exponent rules say that this would be 1/4 to the 1 plus x, which is what we have, right? So we could rewrite this, grouping our constants together, as 6/4 times 1/4 to the x. And there we see, okay, a is 6/4, which is 3/2. B is 1/4. Easy enough. All right. So what about our tables? What we're going to do is, first off, we're going to make sure that our x's are increasing by 1. That's fine. And then we're going to look at, okay, what are my ratios here? Right? 2 over negative 3.25. That's something, I don't know what, but actually I can look at this one pretty quick, because I can say, well, that's a negative ratio, and then the next one, 7.25 over 2, is not even, it's not even the same sign, so there's no way that this is exponential. What it is, though, is linear, because our y2 minus y1, in this case, 5 1/4, and then we get 7.25 minus 2 is 5 1/4, and we've got 12 1/2 minus 7.25, which is also 5 1/4. So this one is linear, so this one is not exponential. What about the last one? So I want you guys to make a habit of doing the higher x value, the y going with the higher x value over the y with the lower x value, for consistency's sake. So we're going to do 49 over 70. We're going to do 34.3 over 49. And we're going to do 24.01 over 34.3. All right, so I've got my little GeoGebra calculator here, and I'm going to calculate all of those ratios real quick. So 24.01 over 34.3, we see is 0.7. 34.3 over 49, also 0.7. This is looking pretty promising here, right? And 49 over 70, also 0.7. So since our ratios are all the same, this one, so the ratios all equal 0.7. Therefore, the second table is exponential, right? So this is a yes, f of x is a no, g of x is a yes, and the other table was linear. All right, so here, this is the same function that we just figured out that the ratio was excuse me, was 0.7. So we've actually done half the work for this already. So there's two ways to look at solving this problem, right? We have A that we don't know and we have B that we don't know. Now, if we had x equals 0 on here and we had a y value for that, we would know A right away, because that's the x, that's the y-intercept, right? But instead what we're going to do is we're going to say, you know what, I got 70 equals A times B to the 1, but I also have 49 equals A times B squared, right? I'm just plugging in these 2 points here. Now you can do one of two things. You can say, I'm going to solve for either A or B and plug it into the other equation, or you can take a ratio, which is normally what I'm going to encourage you guys to do, and you can say, okay, I got 49 over 70 is equal to AB squared over AB to the 1. Like, we're just going to take a ratio of the equations. Of course, the A's cancel, and the powers on the B's, I get B squared over B is going to just be B. So we know right now, because we just figured out that 49 over 70 was 0.7, we know that B is equal to 0.7. And then we can pick any of the points to plug in and solve for A, but I'm going to use the 70 equals A times 0.7 to the 1. And so we can say 70 over 0.7 is equal to A, and that's going to make A equal to 100. Yep. So A is equal to 100. So our formula, or our function, is going to be 100 times 0.7 to the x. And you can pick any two of the points that you're given in the table, and you're going to be able to solve it. But usually you go with the smaller x values. All right, so here we're going to do the same thing, but I'm only going to give you 2 points. So be careful, right? Because in chapter 4, it was find the linear function passing through 2 points, right? Now we are finding the exponential function. And so all we can do here is we're going to say, okay, I've got 1 equals AB to the 3, right? Because remember, this is x, this is y. And I've got 4 equals A times B to the 5. And again, you can do what the equations say, the instructions say to do here. So we could say, okay, I can solve this equation for A in terms of B. Okay, so A would be 1 over B cubed. And then I can say, okay, great, I'm going to plug that into the second equation, the other one. So I've got 4 equals 1 over B cubed times B to the 5th. Simplify that, that's B squared. And therefore B is square root both sides, right? Plus or minus 2, but negative 2 we can't use as a base, right? Because it's got to be positive. So we've got 2. And then we can say, okay, great, I know what A is. A is 1 over 2 cubed, which is 1 over 8. So I've got y equals 1/8 times 2 to the x. And this is growing, so that does make sense. Now, the other option, so that's your usual substitution method. The other option is to say what we did on the first screen, which is to say, okay, I'm going to simply take a ratio. This just kind of bypasses the solving for A in terms of B and plugging in, right? Because we're going to cancel the A's. We're going to say, okay, B to the 5th over B to the 3rd, that is B to the 2. B squared is 4, so I just got there pretty much just the same. B is equal to 2. And then you go plug into either one to solve for A. Either way. So this is substitution, and this is using ratios. Either way will work. All right, we'll do this one and then we'll break for the next video, right? So here we look at this and we say, where is this crossing the y-axis? I know I have the point 0, 2. So right away, I know that A is equal to 2 because A is going to be my y-intercept. Okay. What other points do we have on here? Well, it's really hard to read off what these points are here, so I'm not going to go with those. I'm going to look at -1, and it looks like it's at 6. So that's my other point, -1, 6. So Since we already know A, we can actually plug in. So, right, we have 6 equals 2 times B to the negative 1. So 3 equals B to the negative 1. I'm going to write that as 1 over B. So B has got to be 1/3. So we've got 2 times 1/3 to the x. All right. So, because what happens when we take a fraction and we raise it to higher and higher and higher powers, it gets smaller and smaller and smaller and smaller, right? And if we do negative powers, that's the same as doing the reciprocal. So it actually gets bigger the more negative we go. All right, so that takes us to the number E for the next video.